Did I get it? Is it going? 3, 4, 5. I think so. It's recording. All right. We are on section 3, chapter 11, section 3. We are going to be looking at the development of the formula for the area of the circle. And we are going to use some formulas that we have learned before. Circumference of a circle. Circumference of a circle can be found 2 times pi times the radius. So here's what we're going to do to a circle. We're going to take this circle and we are going to divide it up into all these little sectors. We call them sectors, all these little pie pieces right over here. If I found the area of one of these pieces, or I should say, if I found the area of all of these pieces and added them together, would it equal the area of a circle?
Yes.
Yeah, pretty simple concept. So here's what we're going to do next. We are going to take half of this circle and open it up. And if you opened it up, you would get every other one of these. Can you see that? If I took half of that circle, and I'm going to erase it because it kind of covers it up, you'd get every one of those little triangles there. And then if I took the other half of the circle and opened it up and slid it right on top so it fit in all those little slots over there, you'd get the top half, every other one in the top half. What shape is this? Almost. Not exactly, because these are rounded a little bit there at the bottom. It is a quadrilateral, 4 sides. Parallelogram. It's a parallelogram. Almost, right? Not exactly, but almost, because these are a little bit curved down there. What is the area formula for a parallelogram? Base times height. Now, if we look at the base, what is the base of this parallelogram? Half the circumference, because we took half of it. Took half of it to open up, to do the bottom thing. So that base is 1/2 the circumference. Now the height, what is the height of that parallelogram? It's the radius. It's the radius. The height is the radius of this right over here. So R, right over there. Now I'm going to say 1/2 circumference is 2 pi r, right? 1/2 times 2 times pi times r times r. All I've done is replace that circumference with 2 pi r. Now didn't leave myself quite enough room, so we'll make some more room. If we take half of 2, what do we get? 1. And if I take r times r, what do I get? R squared. You ever seen area equals pi r squared before? Yeah. Now you might be saying, now wait a minute. That's not exactly a parallelogram. And you would be right. So we're going to look at a little animation. Here we have this nice circle. And if I take this circle and I unwrap it, do I get a true straight line? If I unwrapped it all, yeah. And that would exactly equal the circumference, right? Check. I agree. Check again. There it comes. Now, we're going to, when it says dissect, we're going to cut it up, just like you dissect in biology class. But this is, when we dissect in geometry, you notice nothing smells, how it's clean, and see, dissecting in geometry is even better than biology. So if I dissect it into 12 parts, right over here, and then if I started unwrapping this, so here it goes. So we're unwrapping that, and you notice the red was half of it. And then we're going to fold it back over. Then we have almost the shape of a parallelogram, except for all those curved things. So let's back that up a little bit. Put it all back into a circle, and let's cut it into more pieces, and more pieces, and more pieces, and more pieces. We'll do 86, because I like that number. 86. I unwrap it, and I fold it back over. You notice what happens when I do more and more pieces? That gets straighter and straighter, right? And if you could think about, if I could do it into infinitely many pieces, smaller and smaller and smaller, what does that become? It becomes a line. It becomes a straight line. And so it becomes a straight line. Uh-oh, it's not going to let me fold it all the way down because I stopped. I messed up the order. It becomes a straight line in a parallelogram. And the area of a circle, oh, it didn't tell us, is we just developed it a little bit earlier. So I think you can see how, even though right now we start out with curves, if we did it in smaller and smaller and smaller pieces, we say limit. We would limit to exactly straight down there. And that is a way of developing or getting the area of a circle. Area equals pi r squared. So now that we have that, and we have it memorized, we can use it in exciting things like, what is the area of the circular putting green shown to the nearest square feet? What's the area formula? Pi r squared. So if we fill it in, pi times, what's the radius? 10. What's 10 squared? 100. I could call this 100 pi feet squared, or you could, what's pi approximately? 3.14 times 100? 314. You don't even need to go to a calculator for that. Approximately 314 feet squared. This is the exact one, and be real comfortable with that, and it's actually the easiest. And this is approximately down here, 314. Of course, we go farther, right, with our pi right over there. Find the radius of the circle, where they happen to tell us the area of it. Same idea. Area equals, not 1/2. Area equals what? Pi r squared. Pi r squared. So area is 95. I'm just going to fill in my formula. Pi times, what's the radius? I don't know. We don't know the radius. I want to solve for it. How would I get rid of the pi? Divide by pi. I'm just going to write it down. You can start doing it in your calculator. Now that equals r squared. How would I get r? Square root. We want to take the square root of this, and that would get rid of the square part. So the radius is approximately what? 5.5? Yeah. 5.5 Like all the other things we have been doing in this chapter, start by just writing the formula. Fill in whatever we happen to know. The area of a circle is 196 pi square yards. Figure out what the diameter is. Well, once again, area equals pi times the radius squared. The area is 196 pi. There's an exact value. That is pi r squared. Tell me about the pi's in this formula. Cancel out. Divide by pi and they are gone. And so what would I do to get r? Square root of 196. And then what would you do to get the diameter? 2 times 14. 28 yards. Easy stuff. So let's move on to the next idea. This is related to when we learned about lengths of arcs. Lengths of arcs in a circle are some fraction of the what? Length of an arc is a fraction of a what on that circle? Circumference. It's a fraction of the circumference. And so we use the idea of, if I take that angle, or the arc in degrees, over 360 times 2 pi r. That was the circumference. We could get the length of an arc. We'll use that exact same concept over here. When I have a sector of a circle, area of a sector, these little pie pieces, well, that is just some fraction of the complete area. And so we have the same idea. The area of any sector is just x over 360, where x is the degree measure of either that central angle or the arc out there, times pi r squared, because pi r squared is the full circle area. So we'll try it down here. Pizza. Circular pizza happens to have a diameter of 12 inches. It's cut into 8 congruent slices. One of you did it instead of me, so they're all congruent. What is the area of one slice to the nearest hundredth? Well, we know the formula is going to be x out of 360 times pi r squared. How can I figure out how many degrees I have for one of those? 360 divided by 8. What's 360 divided by 8? 360. Got my 8 before I needed to write my 8. 360 divided by 8, 45. 45 degrees. 45 out of 360 times pi times, what's the radius? 6 squared. Now I'm going to do some by hand stuff. What does 45 out of 360 reduce to? You can think about right that over there in that picture. What is it? 1 out of 8. 1/8, which is actually how we could have started. We know we have exactly 1/8 of the circle because we divided it into 8 congruent parts. That would reduce to 1/8. Pi times, what's 6 squared? 36. I'm going to do some more reducing. What goes into both 8 and 36? Does 8 go into 36 evenly?
4.
4 does. How many times does 4 go into 8? Twice. How many does 4 go into 36? 9 times. So if I simplify this, 9 pi is in the numerator. 9 pi. 2 is in the denominator. Over 2. What were we in inches? Inches squared. That is the exact area of that piece. Go to your calculator and give me an approximate one to the nearest hundredth. 9 times pi divided by 2. 14.14 inches squared. There is the approximate area of it. Be able to, Gene and Shelby, thank you, be able to have the exact values. A little bit later, you can do all your work you want. Yes, sir?
I guess we've been able to do the other one because I did got the same answer right there.
What do you mean do it another way?
Well, I mean, like, instead of just reducing everything down, I just actually did the problem 45 divided by 60.
Okay, let me repeat what I'm saying. If you are going to a decimal, then you can just go in your calculator and get a decimal. But if you are asked to give the exact value, then we reduce and get the exact value. You need to be able to do both. So it depends on what they ask, what you would have to do. Find the area of these shaded sectors. Tell me how to start this formula.
But if you ask for an exact value, you can give like a mixed number.
You may give a mixed number. You could have called that, it was 9, what was it, 9 over 2? You could have called it 4.5. That would be fine. 53 out of what? 360 times what? Pi 4 squared, 16. 4 squared. Run it through your calculator because they say to the nearest 10th.
Yeah.
7.4? 7.4 feet squared. I'm going to jump to the end one. I know my formula, area of a sector, is x over 360 times pi times r squared. What area are we trying to find in that picture? Shaded, the blue shaded. What's my x? 360 minus 65. What's 360 minus 65? 295. Run it through your calculator. 295 out of 360 times pi times, what's our radius, 11 squared. Nearest 10th. What do you get, approximately? 311.5? 311.5 inches squared. Hopefully pretty easy. Come down here. Color wheel is a tool that artists use to organize color schemes. If the diameter of the wheel happens to be 10 inches, each of the 12 sectors are congruent. Find the approximate area covered by the green hues, and they have even done it right out there. Something out of 360. Look at the picture. What is it?
That's about 360 by 12, so it's 30.
If you took 360 and divided by 12, you'd get how much?
30.
30? And then how many of those do we have? 3 of them. So what would x be? X would be 90. Or, Allie, what? We have exactly 1/4. You can think of it that way. I have exactly 1/4 of the whole thing. So when you do this, pi r squared, you can just say, I know that's 1/4 of the full circle. Times pi times, what's the radius? 5 squared. Now, I want to start with the exact answer. What's 5 squared? 25. Does 4 go into 25? No. 25 pi times 1, or 25 pi over what? Over 4. And it happened to be in inches squared. That's the exact value when they asked for it. What's the approximate value? Use your calculator. 19.6? 19.6 inches squared. Again, be able to do exact values. Your books. Let's do some stuff together. $800. Number 1. Find the area of each circle, round to the nearest tenth. So we know the area of a circle is pi r squared. So I'm going to write that until it comes out my ears. In other words, the more I run it through my brain, it sticks in there. So pi times what? What will we do? 21 squared. And they want us, I think they say to the nearest tenth answer.
Yeah, 1,385.4.
Is that right? Inches? Inches squared. Number 2. Yard square? Yard square. Number 2, we still know that area equals pi r squared, which is going to be pi times, what's our radius? 0.2, because they gave us 0.2 kilometers, because they gave us the whole thing. Approximately?
0.2.
Nearest 10. 0.1 kilometers squared. Number 3. Find the diameter of a circle whose area of 74 square millimeters. So once again, area equals pi r squared. Our area, we don't.
All right.
74 equals pi times r squared. So how will we start solving this?
74.
74 divided by pi, and then what do I want to do?
Square root.
And then take square root of that. A radius of approximately what? And tell me more than the tenth, because that's not an answer. About 4.85? And if you leave it in your calculator, what do you do next? Times 2, because we want to get a diameter. And again, if you just leave it in your calculator, then round this number. 9.7 millimeters is what you should be getting. Number 4. Area of a circle, 88 square inches. They want us to figure out the radius. So we know area is pi times the radius squared. Area is 88. So we know that we will divide that 88 by pi, and then we will take the square root of it, and that'll give us the radius, and this one is our answer.
5.3.
5.3 if we round to the nearest tenth. At least the book thinks that is. Inches, not inches squared. Radius. Number 5. Find the area of the shaded sector round to the nearest tenth. Set up the formula for me. 57 over 360 times pi times 3 squared, I'm going to call it. Approximately equal to?
4.85.
4.5 inches squared is what you should have gotten. This is a nice one for the day before break, isn't it? Number 6. Set it up. What is it?
92 divided by 360.
92 over 360 times pi times
7 squared.
7 squared. 39.3 centimeters squared. Now in the homework, they can give us different parts that we know, but it's still all using the same formula. So don't become discombobulated. Isn't that a good word? Chelsea, number 7, is baking pies for a fundraiser at her school. She divides each 9-inch pie into 6 equal slices. What do they mean with 9-inch pie? What are they measuring? Diameter. That's what they're meaning when they say a 9-inch pie or a 10-inch pizza. They're talking about the diameter. So A, what is the area in square inches for each slice of pie? What fraction can I start with? You can't start with degrees. Can you go directly to the fraction?
Yeah.
Think of what they describe. Is it 1/6? 6 equal slices. 1/6. We have 1/6 of the whole pie. 1/6 times pi times what's our radius?
It's 4.5.
4.5 squared. So approximately nearest tenth, what's the area of one piece? Oh, nearest square inch. No, they don't say that. They just say nearest tenth. They don't say that. I want nearest tenth. 10.6 inches square. Now the question they should be asking next is, how many calories per square inch? That's what they should have said. Part B. Oh, they want to charge instead. If each slice costs 25 cents to make, she sells 8 pies at $1.25 for each slice. How much money will she raise? So let's set this up. Tell me, what math? What can we do to figure this out?
1.25 6 to see how much each pie costs.
Okay, she's going to sell $1.25 for each slice. So 1.25 times what?
6.
1.25 times 6, that'd be the price that she sells what?
1 pie.
1 pie. And then what would I do?
1.25 times 8.
Times what?
8.
Times 8, because she sells a total of 8 pies. So that's the total amount that she sold everything for. Then what do we need to do? Subtract what?
8 times
0.25 times 48.
Okay, it costs her 25 cents for each what? Each slice. There are 6 slices, there are 8 pies. That is the math that should be able to be done all at once.
48.
48?
48.
I don't know, we'll see. Anybody else get 48? $48.
That's how much she made. Okay.
That's her profit. I don't know. You can buy quite a bit of stuff for $48. Depends on what it is.
Buy some more pie.
A lot of pencils for geometry class. There's just a lot of options of stuff you can buy for $48. Page 800, is that where we are? Numbers 1 through 37.